Okay guys, we're going to just go over some simultaneous equations. Hopefully you remember that simultaneous means something that occurs at the same time. The first thing we're going to look at is how to solve simultaneous equations using the graphical method. The future videos will talk about substitution method and elimination method, and then we'll look at some applications. So simultaneous means occurring at the same time. You can see here there's two lines drawn, one in red and one in blue. The solution to these simultaneous equations is the point where the equations intersect. So from this example here, you can see where I'm pointing to. Sorry, I get my stars where I'm pointing to here. Okay, that point there, the point where x is -1 and y is 1, that point lies on both of those lines, so that is called the solution. We'll explain a little bit more now with some worked examples. So the solution to a pair of simultaneous equations can be found by graphing the two equations and identifying the coordinates of the point of intersection. Obviously we need to graph them accurately on graph paper, etc., or using graphics calculator. They need to be graphed accurately. Worked example 1 from your textbook. They've already graphed these two equations. So here is two equations. X equals, and there is actually a mistake in your textbook here. It should say x plus 2y equals 4, and y is equal to 2x minus 3. So from those two equations, they have been graphed. Here gives you a clue that it's been graphed on the calculator. The solution to these two simultaneous equations is the point where the two lines cross. So the two lines cross where x is equal to 2. So if you go up there, x is equal to 2, and go across here, y is equal to 1. So that is the solution to those two similar equations, solving it graphically. Worked example 1 was relatively easy because they'd already been graphed for us. Worked example 3 from your textbook, we need to graph these two equations. So I'll just give you a little reminder on how to do that. So we need to graph them, and then once we've graphed them, we look at where they intersect. So I'm going to call this one equation 1 and this one here equation 2. To graph them, I want to rearrange them into the form y equals mx plus c. So for the first equation, x plus y is equal to 6. If I move the x to the other side and take x, because I need to do the opposite, remember, when I move it to the other side, I have just made it in the form y equals mx plus c. The gradient of this line is -1. The gradient is the thing with the x, and the y-intercept is 6. Let's look at my second equation. 2x plus 4y equals 20. Let's rearrange this. First of all, we're going to move the 2x to the other side, and we take it. I then need to divide everything by 4 to leave y on its own. So simplifying this down, y equals -1/2 x plus 5. So from this second equation, the gradient is -1/2 and the y-intercept is 5. So using the gradient intercept method, I can graph these. And I've already done it below, but I'll explain how I got it. So for this one here, the gradient's -1, the y-intercept is 6. So I mark in 6. The gradient is -1, so remember I go across 1 and down 1, put another point. Across 1 and down, because it's a negative gradient, put in another point. Hence, that's how they drew that line. For the next line, the y-intercept is 5, so we start with that. There's the y-intercept at 5. The gradient is -1/2. So for a gradient of -1/2, you go across 1, down 1/2, put a point. Across 1, down 1/2, put another point. Then you can join those points up. There's our second line. So for this worked example 3, we had to rearrange the equations into y equals mx plus c form, work out our gradient and our y-intercept for both of these equations. Sketch using the gradient intercept form, so you mark on the intercept, then go across one, down one, whatever the gradient is, mark that on, draw your lines. The solution is where these two lines intersect. So I have scribbled all over it now, but I think you can see that at this point here, the two lines intersect, and at that point, x is 2 and y is 4. So for the solution for this equation is x is 2, y equals 4. So it involved a little bit more work than this first worked example here, where the lines were already sketched, and we just needed to read off the sketch where the two lines intersected. Alright, that's a pretty basic question. The next one, you actually have got to sketch the lines and then tell me where they intersect for the solution. Okay, your textbook talks about equations with multiple solutions and equations with no solutions. Parallel lines have the same gradient. You know that. There's two parallel lines there. Gradient of both of these lines is 2. So those lines are there sketched. They never cross. Parallel lines never meet, so there is no solution. So that parallel lines are an example when there is no solution. Coincident lines that lie on top of each other. Okay, so you can see that from this diagram here. So it's got an infinite number of solutions. Those lines are on top of each other. They don't just meet once, they're basically meeting all the time. So to read up more on equations with multiple solutions and equations with no solutions, look, it's written here, and that's straight from your textbook. So this video just goes over how to solve simultaneous equations. Graphically, we'll now move on to other ways to solve simultaneous equations.